Does the co-host have what it takes to collect and analyze dust data? NASA Edge travels from coast to coast, talking with NASA atmospheric scientists and educators from Project Dust to explore the unique connection between aerosols and climate change.
Franklin, you know, I really think we're wasting time out here. Why is Blair calling us to the beach today?
He seems to think he can do his own dust study.
Dust study?
Yeah. You know, they say that dust can travel from Africa and China all the way around the world, so he thinks he'll find some out here on the beach.
Yeah, that's why we have satellites and special equipment for that. Whoa.
True.
What's he got?
I think that's an air filter.
Is he trying to collect dust with the air filter?
Hey, look, I'm gonna go down here and help him out.
I'll tell you what I'm gonna do. I'm gonna go back to NASA, get on the phone, get somebody out here and show them how to really collect some dust.
Let's do that.
All right. Hey, tell your boy to wear some sunscreen.
Will do. Hey man, what's going on?
Oh, hey Franklin. Wait. Yeah, I just want to make sure if any dust particles I'm collecting, I don't want to get in their eye or anything.
That's cool.
Yeah. Man, not doing too well.
That's just a regular household filter.
Household dust collecting air filter. I mean, that's what they collect, right?
That's true.
Yeah, I'm just not getting anything. I'm starting to doubt whether this whole African dust thing and Chinese dust thing is even real. Nothing.
Let me check your technique again.
Like up here, into the air, collecting. Oh, that's it. Think that'll make a difference?
Yeah.
I can't tell if you're getting anything or not. Bring it down. Oh, snap, pay dirt. Oh, that's awesome, that's great. Oh, hang on, I gotta get data on this. Incredible. All that from altitude, huh? That's interesting. The only thing is now is whether that's African, Chinese, or straight Virginia dust. Oh, inconclusive. Now, Paul, I understand you had a very successful workshop this week.
Yes, we did. We've been spending the week with teachers, helping them understand the role of dust and climate change, or the fact that climate's changing and the amount of dust in the atmosphere is changing. Helped them learn some things, get some ideas, and prepared them to go into the academic school year to develop lessons and video casts for their students to use in helping them learn about this.
You're here in the wild, let's say, and this is pretty far from the industrial complex. Is there any dust that the teachers can actually study out here in the wild?
You know what? That's like that song from Kansas, "Dust in the Wind." There's always dust in the wind. Myself, I'm from Kansas, and we see dust storms all the time. And
wait, you're from the band Kansas?
Well, not quite. From the state, the great state of Kansas, as we say. But there we have dust a lot. But that dust that gets blown up in the air is that it travels around the world. Like one of the things the teachers were looking at was studying the dust from China that can actually go all the way around the world and drop material everywhere across the way, even right here at Syria, Virginia.
That's just mind-boggling. I still can't comprehend that.
It's hard to fathom sometimes that weather, maybe on the opposite side of the earth, affects us here at home.
One of the things that's interesting when we think about climate is it operates on different scales, like different organs in the body. Right. But they've got to work together. And so sometimes something occurs on a small scale, but it actually can feed the larger scale features, larger weather systems. And those larger weather systems control the smaller scale systems, like today will we have thunderstorms or not. So they all interact across these different vast scales. And we can't think about things in isolation. We can't think just about Virginia, but we need to think about our surrounding areas and actually the oceans. The ocean temperatures actually influence our weather here in the winter or the summer. So we need to understand how they feed across these different, out to the oceans and back to the land.
Hey, Richard, so this is really kind of odd to me. A lot of people, when they think of dust, it's something that you want to avoid or trying to get rid of, but you actually study it. Why are you studying dust?
We're trying to study dust to look at its impacts it has on atmospheric radiation and climate. Dust has a large impact on climate because it scatters and absorbs light. And so we here at NASA Langley design instruments, both aircraft and as well as space-based instruments, to take measurements of the properties of dust and how it impacts climate. For example, on this aircraft behind us, we have a LiDAR system, a laser radar, where we send pulses of light. We look at the light that gets scattered by the aerosols, and we provide detailed measurements on the altitude of the aerosols as well as their optical properties, how much of the aerosol is there, how much they scatter, and so on.
And aerosols
Are small particles, either solid particles or liquid drops. If you look out on a hazy day in the summertime, it looks very hazy. Those are all the little small aerosol particles. And dust is another big type of aerosol particle. There's a lot of dust globally.
Dust is also an aerosol,
Yeah.
but what makes dust different from other aerosols?
A dust is different particle. We could have variety of shapes, and we also could be made out of different material. And dust is actually the only aerosol that absorbs sunlight at all range of spectra, from UV to infrared. And in that way, it could affect our climate differently from other aerosols. Because dust is non-spherical and made out of different material, it scatters sunlight very differently. And with satellite, we're actually able to see that scattering process. And by interpreting satellite signal back, we can interpret what dust is made out of, or basically three important terms: size, shape, and composition.
And you said that dust is non-spherical. Spherical aerosols actually have moisture or water in them?
Yeah, most of particles, but for dust, they not hydrated. They made out of little sand particle or little minerals. And minerals, by definition, silicates, they're not hydrated. And so when dust gets in the atmosphere, it doesn't matter if there is some humidity, dust remains non-spherical. And so that's why we have to worry about dust in interpreting our satellite signal.
What are some examples of natural aerosols?
Dust that you get from the Sahara or the Gobi Desert in China, or sea salt. You know, when you look out over waves and you're at the beach and you see all the little foamy bubbles, there's a lot of that produced globally.
So you're literally getting dust out of the ocean?
You're getting aerosol particles called sea salt particles out of the ocean, correct?
We can't catch a break on dust. I mean, it's everywhere.
That's correct.
So what we're trying to understand is really, if something happens in Africa in terms of farm practices or agriculture, or if there's a drought in an area, is how does that change the amount of dust that gets picked up by the winds and transported around the world and comes here? Because there are things that even here we might do differently that can affect what happens in different parts of the world. We are getting more drought. Drought is coming up in Arizona, places like Texas, Kansas, where we're having less rainfall. Is that the land's drying, it's beginning to become more desertified, more like a desert, and we're getting more dust in the continental United States, which will have a large impact.
Now, you mentioned the desert, so in your studies here at NASA, you're actually seeing dust or aerosols from the Saharan desert?
That's correct. We've been in missions, particularly over the Caribbean Sea as well as over the Atlantic Ocean, where we've seen large amounts of dust that come from the Saharan desert. Now, these are transported typically in the summertime or early fall every year. In fact, this dust can have impacts on hurricanes and tropical storms that affect this area. But we also see a lot of dust that comes from China. In fact, even at this time of year, typically March and April, there's a large amount of dust that comes from the Gobi Desert that's transported globally.
Okay, all right. How in the world are we getting dust from the Sahara and China here? How is that even possible?
If the winds are strong enough, the dust can get pretty high in the atmosphere, and with the large wind speeds that we have, they can be transported long distances. I know when you fly in a jetliner, you often run into winds that are 100 miles an hour. Well, the dust typically stays in the atmosphere for several days or up to a week. And so with winds that strong, they can travel large distances.
So when we talk about dust, we're actually speaking about dust storms and how dust is kicked up into the atmosphere. And that's where MISR takes over, right?
Yeah, because MISR can actually track dust transport. It can catch dust close to the source, basically close to that dust event, and then it can track it during transport. And normally, for example, over Atlantic, dust get transported over about 5 days, and MISR can see that dust over 5 days and can say how this dust changes. And what at least we were able to establish right now with MISR looking case study, that dust doesn't change very much, and it only changes when that air get cold and dust fall down and mix with other aerosol in the boundary layer, and then dust property change dramatically. And MISR allowed us to actually study that.
When you talk about these storms, obviously if there's a big storm in a desert, because that's a good source of dust, do you look at that in advance and then try to plan your missions accordingly to kind of get in the thick of it, so to speak?
In some cases, yes. We try to look at forecasts, like instead of just looking at weather forecasts, which are important because we need to know whether there's going to be clouds around. But there are other specific forecasts that try to predict when these aerosols are going to be in the particular region or when they're going to be generated. So yes, we do try to plan our research flights to try to look at episodes where the dust may be higher or more of it, or there may be something in particular that may be interacting with something else with clouds. And so yeah, we try to consult these different weather models as well as these what are called chemical transport models, where they actually try to figure out specifically what kind of aerosol they're looking at, and then we try to tailor our flights to try to match up and see if we can evaluate how well these models predict that.
And which satellites do you use mostly in your studies?
Well, I'm sure you may have heard the constellation, the NASA A-Train.
Of course, the A-Train.
There are several satellites like MODIS, MISR, and Calypso. And Calypso is one of the things that we work with a lot because it's a LiDAR system somewhat similar to what we fly here in this aircraft, where they're flying continuously using a laser to measure the amount and type of aerosols that we see. And so we actually fly a lot right underneath the Calypso tracks to provide data to help them assess whether their measurements are representing the dust correctly and to try to give them some evaluation data.
So you get the data, but you also can help them calibrate their sensors as well.
Right. We try to help evaluate their data or provide them more information about the aerosols that they're seeing that helps them understand how to better analyze their data as well.
Okay, now you're looking at the dust in all kinds of ways, from the Sahara, from China, from sea salt, and you've got all this stuff. How is all this data going to help us understand more about climate change?
What we try to do is we try to work closely with the modeling community to figure out, what are the greatest uncertainties in trying to predict the current impacts of aerosols on climate as well as their future impacts. And some of the biggest things they want to know are, where are the aerosols located in the atmosphere? Okay, the models try to say, well, are they close to the surface or are they farther away from the surface? The farther away they are from the surface, the larger distances that they can travel and the longer times they can stay up. And so our LiDAR data provides a very detailed measure of that.
When you track dust with MISR, it can also act as a predictor for health issues that might arise from dust events. Can you tell us a little bit more about that?
Yeah, actually I was involved in project, so-called MARIS project. That was goal of this project was to link dust with outbreaks of meningitis in Sahel region. And one of theory was that dust is actually hot and dry, and plus it could carry viruses. And a few papers actually show that after major dust outbreaks, it's related to outbreaks of meningitis. And I participated in the project to basically use satellite data, model data, and create predictive system to provide early warning for World Health Organization, and then people actually can do early vaccination. But it's still work in progress. And I think it's very interesting, and it's contributing our understanding of health issues and how dust affects health.
What we need is some kind of industrial pledge that we can just apply to the atmosphere in some way.
Yeah, it'd be nice to do that, but we need dust too.
What would be an example of good dust?
Well, a really nice example of good dust, and it's all that comes out is that some of that dust that, for example, blows off Africa, is that it will transport all the way across the Atlantic and will sometimes, depending on the season, will actually end up in the canopies of the Amazon rainforest. And the Amazon rainforest, think about it, there's not much dirt, so the only place it's going to get it is it's got to come down from the sky. And that's actually part of the minerals that are needed there. Another benefit is that if there's not an overwhelming amount, but some of the iron contents in that dust can trigger some plant growth and some plankton growth, which then is great
like
for fish
vitamin
rearing.
dust.
Like vitamin dust. It's a good way to think about it. But on the other hand, if you get too much, then you get too much algae, then you get a red tide, and that's bad for everything. So, you know, it's kind of a mixed bag. It's been there in all the history of Earth, and we're just now beginning to understand its importance. But it has, just like anything, it's a good side and a bad side.
The most important thing is we need to know more about it, and that's what you guys are doing.
And that's what we've been doing. One of the projects the teachers worked on was how to use the Giovanni, which is developed by NASA, and it's a way to pull data down and look at what's actually happening, taking the satellite data and trying to translate that into the classroom. That's one of the things we'll see at the teachers during this academic year. They're developing some problem-based learning modules, some web quests where their kids are going to deal with data collected by NASA and begin to say, hey, what does this mean and what can we do? You know, because some of it's good, some of it's not so good, but is there a way to find that right balance?
So what's your role in this particular workshop? Are you instructing teachers?
Yes, well, we have many brilliant scientists here. I kind of take the information that they're giving the teachers and create some worthwhile classroom instruction that the kids can understand.
What do you hope that the teachers do when they get back into the classroom?
Well, we definitely want them to take that information into their class. We want them to give the students something practical where they can make a connection between all the high-level science stuff and kind of bring it back home.
What are some of the type of activities that you're thinking about developing or you're in the process of developing for the teachers?
Well, in the beginning, because we are talking about dust and the effect it has on climate, one of the first activities was to ensure that the teachers can distinguish between weather and climate. Right. We actually did an activity this morning where the teachers actually created some non-linguistic representations of both weather and climate. And it's an activity that they can take into their class as well.
So this is a sun photometer.
Yeah, this is sun photometer. Show it to you.
So, just like teachers and students, Franklin, Olga, and I went outside to collect our own dust data using sun photometers.
Wait a minute. Now you can open it and push scan.
Okay.
And now you point to the sun.
Hey, Franklin, look, dust! While this is a perfect way to learn about aerosols and climate, I don't recommend trying to generate your own dust storms. Nature does a fine job all on its own. You got that, Franklin?
Okay, you got data.
Hey, we got data. Hey, you need to do it over this way.
Oh, all right. One dust storm coming up.
Oh, this is nice. Now, we can take this data back and compare it to satellite data?
Yeah, you definitely
Nice.
can.
Hey, Franklin, is this far enough?
Father, don't pay him any money. He does this all the time.
Hey, Franklin, far enough?
Go further. Well, since we got our data, we can get on out of here. Let's go.
Okay.
And I guess Olga and Franklin got all the data they needed without my help. Now, if I could only catch a ride back to NASA JPL, I could help analyze the data. Well, until that happens, you're watching NASA Edge, an inside and very outside look at all things NASA.